Hello everyone and welcome to week 2 of QM. This week we're going to be discussing measures of location. So let's get started. A measure of location, also known as a measure of central tendency, is the most representative or the most typical number in a dataset that describes all the data in a single number. So the three measures of location that we have are mean, median, and mode. And somewhat related to the idea of a median is the upper and lower quartile that we're also going to be discussing today. And we're going to be discussing all of these measures of location within the three data structures that we have. That is the untabulated raw data, the tabulated ungrouped data, and the tabulated group data structures. So let's get started with our first example, which is an untabulated data, which basically means that the data is given in its raw form as just a sequence of numbers or figures that were collected. So right in front of you, you have the daily expenditures of a student within a week. So on Monday, they spent 20 units of some currency that is irrelevant. And then on Tuesday, they spent 15, on Wednesday, 13, Thursday, 13 again. Friday, maybe they went out with their friends, and etc. So they spent a little bit more, 27. Then on Saturday, they might have done some shopping, so they spent 24. And then on Sunday, they didn't go out or something, so they spent a bit less. So the question here that the measure of location is trying to answer is one of what is the average daily expenditure of this person, right? So if we look at these numbers, we can't just select any one of them and say that is the average expenditure that this person is incurring in a day. For example, let's look at the last number, 7. We know that that can never be the most representative daily expenditure of this person. Likewise, if we look at Saturday's figure of 24, then that also seems to be way off. Specifically, it's a bit higher than what we can intuitively feel is the correct number. So the most common response to this question, which is what is your average daily expenditure like, is to just add these numbers up and then divide it by the number of numbers, and that is the most common way of answering this question. So what we do is what is known as the mean. The mean is also known as the arithmetic mean or the arithmetic average. Basically, to calculate the mean, we add all these numbers up, which in this instance is equal to 119, and then we divide by the number of observations, which is 7. So the mean in this case is 17 units of currency. So you can see that 17 seems to be a more representative average daily expenditure than the numbers that we have up top. You can see that it is not too close to 27, but also not too close to 7 at the same time. So it's somewhere in the middle. Let's formulate our thoughts here into something a bit more formal, and that is that the mean is the arithmetic average of all the observations that we have. So what that means is we have to sum all the observations that we have collected, which is denoted by this sigma symbol that we have here, right? This one here, which is known as the sigma notation. So it's the Greek letter sigma, which symbolizes you have to add everything that is given as an argument for it. So if we look at here, it just says that this sign is telling us to add all these x's up. So x starts from the kth observation, which here is from the first up until the end, and here means the total number of observations that we have. So in our example, that's going to be 20 plus 15 plus 13 all the way until we add those all up. And then we divide it by the number of observations that we have, which is 7. That gives us 17. Right? So this is the formula for how to calculate the mean. Let's move on. In our second example, we have the commute time of a student from their home to their university and the number of minutes that it takes. Presumably, the student lives very close to the university. It takes around these times to get to the university. So you can see that on Monday, they got to the university in 9 minutes, on Tuesday 12 minutes, Wednesday 10, Thursday 11 minutes. But then on Friday, if you notice, it took them a bit more than usual. So they might have spent some time stuck in traffic. There might have been a traffic accident which caused delays and etc. And basically, they took a really long time to get to the university. Now, if we try to answer the question, what is the typical or the average commute time of the student using the mean, it's going to be a bit misleading. So let's try to compute the mean of this data. We take the sum of all the numbers that we have. It's 85. We divide by the number of observations. That's 5. We get 17 minutes. Now, straight off the bat, you can see that 17 does not seem to be uh, representative of the typical amount of time it takes for the student to get to the university. So you can see that the first 4 days it took much less than 17 minutes, but then on Friday, because of unseen circumstances, it took them much longer than necessary. So using the mean to describe the average of this data seems to be a bit disingenuous. So instead, what we can do is calculate what is known as the median. Now, the median is different from the mean in that it does not require all of these numbers to be calculated or to be added up. Specifically, the median is defined to be the centermost value of the data when it is arranged in some order. Specifically, it is that particular value where in an order, 50% of the ordered data is less than the median, and 50% of the data is higher than the median. So let's get started and put these in an ordered list first. So we're going to start with 9, that is the first smallest number. Then we go with 10, then 11, then 12, then 43. Right. So straight off the bat, you can see, because this is just 5 numbers, that the centermost value is 11. Now, if someone were to ask you what is the typical time that it takes for you to get to the university, and these are the number of the minutes that it takes for you to get to the university, then 11 would be a more typical example of how long it takes you to get there than 17. So to calculate the median, we need to figure out which number in our ordered list will become the median, or that we need to select as the median. That's given by this formula here. So if we have n observations, we need to add 1 to it and divide by 2 to find the centermost number that we have. So in this case, that's going to be 6 divided by 2. So we need to select the third value. And again, that is 11 in this example, and that is our median. Now, if you have an even number of observations, let's say 6, so let's put in another number here. So it took them 13 minutes the next day to get there. Now, the median value is not going to be a whole number. So in this case, it's going to be 6 plus 1 divided by 2. That will give us 3.5 as the number that needs to be selected. Now, we cannot select the 3.5 number that does not exist. So in that case, what we do is we take the mean of the third and fourth values. So in this case, that's going to be 9, 10, 11, and 12. So this is the first, second, third number, and fourth number. I just take the average of those. That will give me 11.5 as the median. Let's move on. In our third example, we have a different type of data that is being collected. You can see that these are not numbers that are being collected about other people, but instead these are the toy preferences of young children. right? So a survey was conducted asking young children what their preferred stuffed toy was. 9 replied with stuffed bear, 6 with stuffed elephant, and 5 with stuffed dinosaur as their preferred toy. Now here, when we ask the question, what is the representative or typical toy that a child prefers, we cannot use mean or median to calculate some sort of average in this instance, because the data here is nominal. Instead, what we do is we calculate the mode, and the mode is basically the most common or the most frequent data that we have in our data set. So in this case, the measure of location or the measure of central tendency will just be stuffed bear. Right. Let's go back to our first example and try to apply the median formula and figure out what the median is going to be. So again, what I need to do is figure out which value here I'm going to select as my median. So there are 7 observations that I have. So that's going to be 7 plus 1 divided by 2. That would mean I need to select my 4th value in an ordered list as my median. So that's going to be, let's put these in order first. So that's going to be 7, 13, 13, and then 15. And I can just stop right here because this is my 4th value and this is going to be my median. Now, let's try to find the mode from this example. Right? And as you remember, the mode is the most frequent observation that occurs. You will see here that all these numbers are unique except for 13 that repeats twice. So in this case, my mode is just going to be 13. Now, if you remember, the mean of this example was 17. So as you can see, these different measures of location, specifically the mean, median, and mode, they don't necessarily have to give you the same result. Each of them have their own advantages and disadvantages in trying to tell you what is the most typical or what is the most frequent number. So this is a recap of what I have just done. Let's move on. Right. Now let's try to find the upper and lower quartile from example number 1. So lower quartile is basically the 25th data that I have. Right? It's very similar to the median because the median is exactly the centermost data that I have. This is how we calculate the median. It's also known as the middle quartile, and then after the median comes the upper quartile, which is the 75th data that I have in my data set. So if we go and try to apply the lower quartile and upper quartile formulas to this example, we'll see that again we have 7 observations. That is going to be 8 divided by 4. So I need the second observation that I have. So let me just put it into an order here. So that's 13, 13, 15, okay, 20, 24, and 27. So right off the bat, the centermost number that is the median, right? And if we look to the left side of it, we can see that we have 3 numbers left, specifically 7, 13, and 13. And if I select the centermost from that, that is going to be my lower quartile. Similarly, if I look at the right side of my dataset, I see that I have 3 numbers remaining, and if I take the centermost data from this upper side, that is going to be my upper quartile. Now let's move on to example number 2 and try to figure out if we can calculate the mode from this example, right? And you'll notice that all of these numbers are unique. None of them repeats itself. So as a result, from this example, we notice that a mode does not exist. And this is somewhat the case in all discrete variables or discrete data that you collect, that it does not necessarily have to repeat itself, and as a result, you cannot find the mode. Right. Now, let's move on to tabulated ungrouped data structures that we have. So tabulated basically means that the data has been placed in a frequency table, which we have already done in seminar number 1. So I hope that is something that you guys are already familiar with and that you know. Um, Ungrouped data basically means that these numbers have not been analyzed and have been distorted or changed in some way, and that is these numbers have just been put into categories and the number of frequencies that this number has occurred is recorded. Let's look at example number 4 as a demonstration. So a particular amount of TV sets have been sold over the month. So over 30 days, every day some number of TV sets were sold. So we can see that over this course of the month, on 4 days only 3 TV sets were sold. On 6 days only 4 TV sets were sold. On 7 days 5 TV sets were sold, and so on and so forth. Now, let's try to calculate the mean, median, mode, lower and upper quartile for this example. Right. So, in this example, if we want to calculate the mean, we can no longer sum up all the values that we have because unfortunately the raw data is gone. It's now been tabulated into a frequency distribution, into a frequency table, and as a result we're going to have to use that information in trying to figure out what the mean is. Fortunately, it's not that complicated because we know that our observation of 3 has repeated itself 4 times. As a result, instead of adding something 4 times, we could just multiply it because that is basically the same thing. So in this instance, that will give us 12, and I keep doing that with these 2 columns that I have. And then at the end, what I do is all these numbers that I get, I just take their sum. Their sum in this instance is 158. I divide it by the total number of observations that I have. Remember, it was over the course of a month, so that's going to be 30 days. And if I take 158 divided by 30, I get 5.3 as the median. So the average number of TV sets they have sold in a day is 5.3. Now let's talk about trying to calculate the median from this example. Again, the median was the centermost value that we have. In this case, we have 30 days of observations. We add 1 to it, divided by 2, we get the 15.5 number as a result. Now, to be able to figure out where this number lies in our data, we're going to have to compute the cumulative frequency, which we have already done last week in seminar number 1. So I hope that you guys already know how to calculate the cumulative frequency distribution. And what we have to do is figure out under which category or under which observation class this number resides. So 15 is larger than 4, so it's not under number 3. It's larger than 10 as well, so it's not under number 4. We can see that it's lower than 17, so my median is now going to be this number. Right. And a quick reminder, you have to calculate the cumulative frequency to be able to figure out what the median is going to be in a tabulated ungrouped data set. Right, so now let's calculate the mode. The mode is among the easiest to calculate from a tabulated ungrouped data structure. All what you have to do is basically look at the frequencies and select the observation that corresponds to the highest frequency. In this case, the number 7 is the highest frequency that we have. As a result, our mode is going to be number 5. That is 5 TV sets or the most common number of TV sets that were sold during a month. Now let's try to calculate the lower and upper quartile. Since this data is even, it's much easier if we split the data into two groups. That's going to make our lives much easier. And the way we split it is we figure out what the median is. All the numbers below the median are split off into a separate group. All the numbers above a median are also split off into another group. Now, if you remember, the median was the number 5, so we're going to have to split it from this number. And basically, since we have 30 number of observations, we're going to have to split it up into groups of 15 days, right? So if you notice that 4 plus 6 is 10, but plus 7 is 17, that's more than 15. So what we're going to have to do is drop the last two observations of 5 TV sets sold per day. So this is what it will look like. The first table that you have is the group with the TV sets or number of observations that were recorded that is below the median. And the second group is all those numbers that were higher than the median. Then once we have that as separate tables and separate groups, what I do is we calculate the median or use the median formula on it and figure out what the quartiles are going to be. So if I use the median formula on the first group of observations that I have, that's going to be 15 number of observations plus 1, that gives me 16. Divide by 2, that means I'm searching for the 8th value in this table. As a result, that's going to be the number 4. That is our median number of TV sets sold, because the 8th value is higher than 4. It cannot be inside 3. As a result, it is lower than 10, so it resides within this category. Applying the same thing for upper quartile, we get again 8th value. That should come as no surprise because we're trying to split it up into 2 equal parts. 8th value, that is higher than 2, so it is not inside 5. It is exactly at the number 8, so that is going to be 6 as our upper quartile, or the upper quartile for the number of TV sets sold. Now let's look at tabulated grouped data structures. So in this example here, we have the amount of money spent on food by 50 people in a particular shop. Now we couldn't just record the amount of money that they spent and the frequency at that particular money has been spent, because it really doesn't make sense. For example, if someone paid $3.52 cents on something, then nobody else is going to spend that much amount of money. So tabulating it in an ungrouped data structure doesn't make sense. So that's not what we're going to do. So instead, in here, it has all these observations that were recorded has been put into small ranges or small categories, and then the number of observations that fit into those ranges were recorded. Now, if we want to calculate the mean, median, or mode on this example or on this data set that we have, then we're going to have to make some assumptions, because if you remember, when calculating the mean on a tabulated ungrouped data set, we had to multiply our observation with the number of respondents or the frequency that we had. But in this case, our observation is actually a range. It's not a single number. We cannot multiply a range by a single number. Now, if I were to try to calculate the mean, median, and mode on a tabulated group data structure, I'm going to have to make some assumptions because My observation here is not a single number, it's actually a range of numbers, and I cannot multiply a range of numbers with the number of frequencies. It doesn't make much sense. So what I'll have to do is assume that all of these ranges take on some sort of number, and the most obvious or the most relevant assumption that I can make is that I can take the midpoints of all of these ranges as the most typical value that each range of numbers would fall in. So the midpoint of 0 and 5 is 2.5, the midpoint of 5 and 10 is 7.5, and so on and so forth. Now, once I have made that assumption about the observations that I have, or the range of observations that I have, what I can do is I can multiply the frequency with this midpoint and come up with a number that I can add on to the rest of the numbers that I have here. And once I have done that, I get these numbers, and then all what I do is I add them all up, and I get 995. I divide it by the total number of observations that I have, and that's going to be 50. So 995 divided by 50, that's going to be 19.9. So the average or the mean expenditure on food from this particular data set is 19 pounds and 90 cents. Now let's talk about how to find the median of a tabulated grouped dataset. You'll notice here that the formula for the median is this nasty looking thing, but don't worry, it's going to be very straightforward. It actually is very simple once you have understood what it signifies, right? So let's just try to apply this formula first and figure out what the median is, and then we're going to try to look at it from a visual perspective, right? So L is the lower boundary of the frequency group where the median resides in. Now, to be able to figure out what L is, we have to figure out what frequency group the median resides in, and that's very simple. That's going to be n divided by 2, so we are looking at the 25th value, and we have to search for where that is. So if we look at our cumulative frequency, 25 is higher than that, higher than that, higher than that, and it's going to be within this group. Now notice that the median formula to figure out the value under a tabulated group data structure is different than the one that we used for raw and tabulated ungrouped data structures. And the reason behind it is that this is a continuous data. So all these ranges that we have here, they take on a continuous range of numbers to be the typical number that it could be in, and as a result, we don't have to do the correction as we do under discrete data that we have, such as in an untabulated raw data set or a tabulated ungrouped data set. Something to keep in mind. So the 25th value is going to be more than 15 but under 20. As a result, L is going to be 15, as you can see here. Then we add on the width of this group. That's just going to be 20 minus 15. As a result, that's 10. Then we have n divided by 2 minus f, capital F. So capital F is the cumulative frequency up until the median group. That's going to be 16, as you can see here. So that's why we subtracted 16, divided by the frequency that the median group occurs in. So that's going to be 14. And if we figure this out, then we can see that the median number in our instance is 18.2. Now let's try to look at this visually and let's see what's going on. Right? An easy way to think of this would be to just cross off the lower numbers and the upper numbers one by one until I come to the center number, as we have done with a raw data set. So let's try to do that. So it's not going to be the lower two numbers. That's obvious, and as a result we can also cross off the uh, top two numbers. It is not the remaining top six numbers, and we can cross off the bottom six numbers as well. Then now it's not the remaining bottom eight numbers, right? And as a result we can cross off the top eight numbers as well. But since we have 12 inside here, the 4 should remain. Now let's cross off the 4 top numbers that we have, and as a result we can cross off the bottom numbers here, right? So we are left with 10 numbers within the range of 15 and 20, and the median is going to be the centermost number over there. So let me draw this in a timeline, right? So these are the number of observations that I have. These are going to be the expenditures that these respondents spent. So in the top, under the cumulative frequency, I'm going to write here 30, and the lower boundary for this is going to be 16. So basically I took these two numbers and I put them there. Now I know that the top part of this range is 20, so this is here 20 pounds, right? And on my 16th observation, I have here uh, 15 pounds. Now, if you remember, the median was the 25th observation, right? So this is the 16th observation, right? And what we need to do is to come up with the 25th observation that I have here, right? So let's just look at this small part here first. That's going to be n divided by 2, that's 25. I subtract from it this number 16, and then I divide it by the size of my frequency group. That's going to be 14, right? As a result, this is going to give me the number 9. I multiply it by 5, which is the width of this group, right? Basically, the number 9, what it says is once I have stopped at the number 16, I have to go 9 more steps to get to the number 25. Or another way to look at it would be the this 4 that we had crossed out. We're going to have to cross out the first 4 observations that we have within this frequency group. And we're going to be left with these 10 numbers, and the most relevant assumption that I can make here again would be to take its center point. As a result, it's going to be the 25th observation. Now I need to know at what pound amount that is going to be. So basically what this says is we stopped here at 16th observation, and the 16th observation had 15 pounds as the observation amount. So I have here 15. I add to it the size of my median group, that is 5, but of course I don't want to go all the way till the end, because if I added all this 5, then the answer would be 20. It's actually a little bit less. In this case I have to go 9 steps out of a total of 14 steps here to get to my median number. As a result, this is going to be 9 over 14, and at the end this is going to equal to 18.2. I hope that was more or less straightforward in how this formula is trying to figure out which is the median point. So the median number is going to be this 18.2 over here. Now let's talk about the mode or finding the mode of a tabulated grouped data structure, right? The formula for mode is also a bit unwieldy. As you can see, it's rather large, but again, it still has the same principles as finding the median of a tabulated group data structure, right? So again, it has the same definitions, right? Where L is the lower boundary, but this time not of the median group, but the modal group. W is the width of the module group, and what I'm trying to find is how close it is to this or the other. Let's just apply the formula first, and then we are going to discuss a visual interpretation of what this formula is trying to do, right? So the module group is very easy to identify. The module group, it will be the group with the highest frequency. So in this case, that is going to be between 15 and 20. As a result, the lower boundary of my model group is 15 right over here. To that, I add the width of my model group, that is 20 minus 15, that's going to be 5. And then what I'm trying to do is trying to take the proportion between the frequency of uh, my pre-modal group and my modal group divided by the distance between my pre-modal group and my modal group and my modal group and my post-modal group. I'm just trying to take the proportion of these two numbers. So let's try to look at it visually and see what's going on. So I think it's best to draw a histogram to try to convey what this is trying to say. So this is going to be the frequency of my pre-modal group. Let's say it is this thing over here. So this is equal to 8. And then I have my modal group that is going to be this thing over here, right? So this is 14. And then I have my post-modal group, and that is going to be 12 here. And from this visual perspective, you can see that what I'm trying to figure out is which number which number has the highest. It's going to be 15 plus 5, 6 over 6 plus 2, that's going to be 8, right? As a result, this is going to equal to 18.75. As a result, you can see that it's not actually the center of the module group. So the module group was between 15 and 20. So the center point is 17.5, but it's actually much closer to the post-module group because its frequency is a bit higher than the pre-module group. As a result, the mode for this example is going to be 18.75. Now let's talk about finding the lower and upper quartile for tablet group data structures. The principle behind this is similar to finding the median of a tabulated group data structure. So we're going to use the same formula almost. So the only thing that's different here is this number over here, which shows you that we actually are trying to find the n divided by fourth number here. So in this case, that's 12.5. So we're trying to figure out where 12.5 resides in this cumulative frequency column over here, right? So 12.5, it's larger than 2, larger than 18, so and smaller than this, so it is within this group over here. So this is my lower quartile group. Then I apply the same formula that I had under median with the slight modification that this is going to be n divided by 4, and as a result I get 12.8 as my lower quartile number. Similarly, in upper quartile we follow the same logic, but now we're not trying to find the 25th value. We are trying to find the 75th value. So that is going to be the 37.5 value here. So that's going to be larger than this inside here. So this is my upper quartile group. Then I carry on with the same formula that I had with a slight modification, that this is going to be trying to figuring out the 75th number in my data set. And as a result, we get 26.25 as my upper quartile number. This is it for our discussions for QM for week 2. I hope you enjoyed it, and see you in the seminars.